So now let us proceed to chapter 2 of your data structures and algorithm subject. So chapter 1, as discussed earlier, so it deals with the data structures, the different data structures. Now we will be dealing with algorithms. Ano itong sinisaring algorithms? As indicated in your chapter 2 assessment, it said that you are going to write down your day-to-day routine. For example, how will you cook something? Let's say, for example, you are going to cook rice. How will you do it? Okay? What are the processes or what are the procedures to cook rice? So that is algorithm, the process or the procedure. Every day we deal with algorithms. Okay? So in computer science, basically, it is defined as your uh, set of steps or set of instructions, or other definition is a set of procedures or the process to complete a task. For example, you are going to make a cup of tea. Paano iton paghimo hiton cup of tea? So the algorithm for this is, number one is you need to add water and milk to the kettle. Second is, of course, you're going to boil it and you need to add some tea leaves. And after that, you need to add sugar and then it's already ready for serving. So again, algorithm is a process, step by step process or procedure or instruction to complete a task. Did you get it? Okay, let us proceed. Now, here is another term that is involved in computer science. So this is, since we defined already algorithm, so let us define a computer algorithm. What is the difference between the two? Now, as defined here, your computer algorithm is a set of steps to accomplish or complete a task that is described precisely enough that a computer can run it. Okay, so the difference is, uh, in our day-to-day life between a computer algorithm, because of course your computer algorithm involves a computer to run it. However, the similarity of this is because it follows the same step. Okay, parehas na step. It follows a step-by-step process such that computer algorithms involves computer so that we can run a certain task. Okay, so now an algorithm represents a solution to a given problem. Okay, now your algorithm, specifically your computer algorithm, is independent from any programming languages. What does it mean? So actually, there are different programming languages. What programming languages do you know? Are you familiar with Java or let's say C++ programming language? Okay, so those are some of the programming languages. Okay, So, damo Python programming languages like Android, okay? Android. That is used for developing mobile application. So, ibig sabihin hini na statement, it is independent from any programming languages. Independent meaning it can stand alone. It means that bisan ano nga programming languages it imo gamiton, it can stand. Okay? Waray niya, kumbaga, it opposite. There hiya maran la ha Java, there hiya maran ha C++. But all programming languages can utilize algorithm because it is independent. Okay? What are the characteristics of an algorithm? First is, it must take an input. May dapat niya input. Let's say, for example, when you are making a program in C++, because I will be introducing to you C++ because you are done with programming 1. Okay? So, asya mat iyo, kumbaga, familiar. So, it must take an input. Let's say, for example, your program, nasa rin, create a program that inputs a grade. Tapos, after pag-input it grade, it will output if the grade nga imo gin-input is either passed or failed. Okay? So, dapat makuha yan input. So, that is the algorithm or process. Now, the second characteristic of an algorithm is it must give some output. It's either yes or no, a value, or a message. Again, example, a grade. It's either pass or fail. Let's say, for example, my input is 80. Para di dahil ito grading system, ha? Elementary or high school. Di ba? Ito passing grade is 75. Okay? 75. Let's say I inputted 80 a grade. So what would be the output? Masaring the output passed. Okay? So dapat your algorithm should give some output. And your output is passed. Kung ako naman input is 68. So may na input, di ba? Now, the output should be failed. So pasok pa hiya itong aton characteristics of an algorithm. Another characteristic is definiteness. It is defined. It is clear and unambiguous. Clarado, dere ma lipong haulo. Okay? And then finiteness. When I say finiteness, it terminates. When I say terminate, it should end or it should stop after a finite number of steps. May niyahangganan. Waray forever. Diba? Another is effectiveness. Every instruction must be basic. Basic la. Dapat. And then, to make it effective, it should be simple. Okay? Simply. Very complicated. So those are the characteristics of an algorithm. Okay, nakuha. Okay, let us proceed. What do we expect in an algorithm? So here are our expectations. So we have actually two expectations only. Number one is correctness. Paano kita makakasaring nga correct? We can say that the algorithm is correct when it produces a correct result. Okay? What if it produces an incorrect answer? Makakasaring ba kita nga dere asya itaton gin-expect? We can say that it is still correct. Okay? How? As stated here, even if it fails to give correct results all the time, still there is a control. Makokontrol naton. Kumbaga, di man natin masisering nga 100% correct, but somehow it gives us 95% accuracy. Pero man iton vaccine, di ba? Inya na nga vaccine. May dan natin sinisering nga efficacy. Ba? May dan nasering nga 95%. So, diri nga tanan. May gihap niya flaws. Kumbaga, may niya failure. And then another is approximation algorithm. So, the exact solution is not found but near optimal solution. Kumbaga, ibig sabihin, di rahiya ang pinaka-best but somehow harani na hiya to the optimal, to the best solution to a problem. It will be considered as, it will be still considered as correct. Okay? Nagets? Okay, let us proceed. Another is less resource usage. Algorithm should use less resources. It should use less time. It should use less space. Dapat magurugot itong time nga makukonsume as well as ang space or the memory nga magagamit. Okay? So those are your expectation of the algorithm. Now, in algorithm, there are terminologies that arise. Let's say your pseudocode. What is a pseudocode? It gives a high-level description of an algorithm without the ambiguity associated with plain text, but also without the need to know the syntax of a programming language. If you'll notice, now, in this semester, I guess you are, you have been introduced with Java, di ba? Java. In programming 2. And in programming 1, you utilized C++. Ano yung napapansin? Di ba magkaiba iya syntax? Let's say for example, a C++. Ang iyo ginamit nga pag-output is nasa ring. C out. Ba? C out. Ha Java naman, nasa ring it iya pag-display. System.out.println. Okay? So magkaiba it iya syntax. Your pseudocode itong gamit is gindi-describe lang niya kung paano. It's somehow your algorithm is can be shown or can be expressed via pseudocode. Pwede gamiton pseudocode. Okay? What is the difference between pseudocode and algorithm? Your algorithm is a formal definition with some specific characteristic that describes your process, while your pseudocode is an informal and human readable. So, your pseudocode is human readable. Maintindihan ito ng human. Okay? Let's say, for example, this one. Here is your algorithm. This one. Your input, here, and then your step by step. And then your pseudocode is this one. Parang program-like na yan. Okay, let's move to performance and algorithm. How do we measure the performance of an algorithm? So there are two. So we use two approaches to determine the performance of the algorithm. One is a posteriori analysis, and the other is a priori analysis. When I say a posteriori, that is implementing the algorithm in a machine that is then calculating the time taken by the system to execute the program successfully. So meaning, it is the measurement of a program after na niya pag-run. Diba? When you're going to run a program in C++, may da niya didit ubos kumpira in iya running time. It can how much time does it take to run a program? May dala kumpira ka seconds. While the a priori analysis, it is done before, okay, a prior before the implementation of the algorithm. So it is done. Example, this question, if it how long the algorithm takes, compare, or how fast the function that characterizes the running time grows with an input size. Okay? So doha, a posteriori, so may post, a post meaning tapos na. A priori is before. Kumbaga, estimate mo ano priori, estimated time pala. While on the posteriori, ano yan talaga exact time nga pag-accomplish an algorithm. Okay, so here is another term, algorithm design. So, algorithm design. So, Donald Knott named the name who introduces us the analysis of algorithms. So, it is as computer science field of computer science which studies the efficiency, meaning the paano natin ma-describe nga efficient algorithm because it uses less time and less space. Now, algorithm analysis provides theoretical estimation for the required resources of an algorithm to solve a specific problem. And analysis of algorithm is the determination of the amount of time. So it focuses on the amount of time or the time complexity and the space complexity. Ang natin magagamit na time and the space to execute that program or algorithm. So your time complexity is the amount of time to execute the running time. While on the space complexity, the amount of memory and that you use, memory or the space, it is ada natin makukuha iton space complexity on the variables, program instruction, and execution. Okay? Instruction, space, and iya components. So instruction space is the space needed to store the compiled version of the program instruction. Okay? And my instructions, for example, return, print, ano pa, cn, ganyan. Environmental stack naman, a function may be called inside another function. So meaning, pwede pa ko na iya ma-utilize ito sa mga function. Say, doon ang program, define kita sa mga function dito sa program. And then, another other program may call the function dito sa mga program. So, babahato naman niya, i-store la ini nga function dito sa nga stack. Stack is a data structure nga pwede natin gamit. Okay? So, i-store lang niya para for future use. Then data space. Data space is the space needed to store all the constants. Mga constants are not changeable and variable. Okay? So here is the calculation. Here are the data types. For Boolean character, it takes 1 byte. For the integers, wild character, it takes us 2 bytes. For float, integer 32, integer long, it takes 4 bytes. For double naman, it takes us 8 bytes. Okay? How do we calculate this? For example, this one. And z equals to a plus b plus c. So this we'll be using this one to get the space complexity or the amount of memory that is used with this program, with this line of codes. So integer, di ba? So again, pera itong integer, adihiya, that it takes 4 bytes. And then, so meaning, itong z, a, b, and c are of type integers. So now, your z takes 4 bytes. Your a takes 4 bytes. And then another is b, it also takes 4 bytes. Then your c, it takes 4 bytes. And then for return, kasi that is ano niya? Return value or the instruction, it takes 4 bytes. So we are going to add them. So the total memory that is being used with just this line of codes takes 20 bytes. So ha? Ito pala. Okay. Another. What about this? So this one is an array. So kung array ko no, when we are using array, it takes 4n on array. Then n, 4 because that is an integer variable. Then your x is an integer. Your I is an integer. Di na kita magamit n because adinaya and also with I. Di na kita magamit itong x because it's already here. So this one takes 4 bytes kasi return value. So we add them. So it takes 4n plus 12. So paano naging 12? 4 plus 4 plus, sorry, 16. Sorry, that should be 16. Sorry, that is 16. Please correct. 4n plus 16. 4 times 4. Sorry, same. Okay, so algorithm design goals. So the goal for algorithm design is, of course, to save time, to save space, and to save face. When we say to save face, that is to retain the integrity of that program. Okay. Let's move to classifications of algorithms. So we have here classifications of algorithm. We say one, ito usang algorithm if it takes constant. When you say constant, mga numbers, integer numbers, and then it might change like 0 to 1,000 mga numbers or more. Basta, it takes constant. 1. Log n if it is logarithmic. So again, may that niya hierarchy. It pinakabobo is constant, followed by logarithmic, log n. Then n, when the running time is linear. And log n naman, if it is a combination of logarithmic and linear. Then n squared for quadratic, n cubed for cubic, 2n if it is exponential. So, tikang habobo, mga classification of algorithm to pinakahataas. Later, we'll be using this one. Okay? Example. Okay, how do we calculate the complexity of an algorithm? So, it depends on the size. So, we have here our cases, as mentioned in chapter 1, best case, average, and worst case. Best case kung pinakaguti, minimum. Average naman is the pinaka-middle, expected value of n. Worst case naman is the maximum or pinakataas nga execution. So we have here asymptotic notations. What is the use of this? It is a way to describe the characteristics of a function in the limit. Limit describes the rate of growth of functions. It is a way to compare the sizes of the function. Okay, so here are the asymptotic notations. Big O, O, big omega, big theta, little o, little omega. But for this, we'll be focusing on big O notation. Okay, usually. So here, big O notation. Theta and omega. So we'll be focusing on big O notation. So we'll be discussing to you the rules for using your big O notation. Number one is ignoring constant. Ignore mo. For example, this one, this function, 20 and cube. So rule number one is ignore constant factor. Handy that constant. That is 20. So ignore mo here. Eliminate mo. So the complexity of this is big O of n cube. In cube. Because you are going to ignore. And then rule number two is ignoring smaller terms. Example. So this one, n cube, n squared plus n. So magorogoti iton n. So i-ignore mo hiya, i-eliminate mo hiya. So it becomes big O of n squared. Nakuha? Ignore mo. Again, ignoring constant and ignoring smaller terms. Number three, upper bound only. So madarada ko. For example, this one. O of n, logarithm is also of O n squared. So, magorogote iton n, so pwede siya ma-consider na square. But not vice versa. Di mo matatawag hiya nga n squared kon O of n lang. N and log n are bigger. So if k is a constant, so on 1 plus constant, so using rule number one, ignoring constant, so it becomes O of n. Example also this one, log n plus your constant, we ignore this, so it is O, big O of log n. Okay, example, this one. What is the complexity of this function? Your function is 10 log n plus 5n plus 3n squared plus 6n cubed. So we'll be using the rules in big O. So anon rule number one, it is ignoring constants. So ang mahinanabo, it becomes log n. Okay, cancelled here. Then naman, magiging n na lang. Kaya ignore mo adi nga 5. And then for this one, ignore 3. So magiging n squared. And then this one naman, ignore 6 kay constant here. So, asinit mo hinanabo. Here. Okay? Now, for number 2 rule, ignore smaller terms. So, log n, and madara ko log n ngit n. Okay, ma-eliminate hera. So, it maglalaban na lang dida n squared and n cube. So, madara ko iton n cube. So, this function takes big O of n cube. Kuha? Okay. I guess that's all for this morning. And thank you for listening. God bless.